Hi, I'm Mike with MSA. As most of the world and our country is currently locked down under quarantine, we wanted to put together this video to give you some training tips for those who are still working in an industrial setting making our goods. So I hope you're all healthy and safe and enjoy the video. MSA was founded in 1914 and is headquartered in Cranberry Township, Pennsylvania. MSA is a manufacturer of safety products with 4 core product groups. The first is head protection, the second is gas detection, the third is respiratory protection, and finally the fourth, and what we're here to talk about today, is fall protection. When I talk to groups about fall protection, I like to start at the beginning. In 1969, it was estimated that between 10,000 and 12,000 workers lost their lives that year due to falls from heights. Because of that amazingly large number of fatalities, Congress decided to step in, and in 1970, they passed the Occupational Safety Health Act, leading to the formation of OSHA. OSHA's job was to develop a set of standards to make sure that workers were protected and workers were safe on the job site and they went home at the end of the day. One of the first standards that OSHA implemented was the fall protection standard. In short, the fall protection standard then said that if companies are putting workers working them from heights, then they have to be protected, either by passive means, such as a guardrail, or by PPE and fall arresting equipment. What that means is that companies had to supply the PPE, and in 1970, that consisted mainly of a lanyard and a body belt. However, as time went through the 70s, 80s, and 90s, it was evident that the lanyard and the body belt still weren't enough to protect workers. Many workers were still losing their lives, and many workers were still being permanently disabled as a result of falls. In 1998, OSHA revised the standard to say that body belts were no longer allowed, and that if PPE was needed for fall arrest, that shock-absorbing technology had to be implemented. The reason is the forces that are put on the body during a fall. A 220-pound person falling just 6 feet can generate over 3,000 pounds of force. That's enough to kill you, break bones, and damage internal organs. Therefore, OSHA changed the standard and you will not see a body belt on my truck. When OSHA developed the fall protection standard in 1970, they created what is called the hierarchy of control. And this consists of 4 points. The first is to eliminate the hazard. The second is to engineer out the hazard. The third is administrative controls. And the fourth is PPE. Let's talk about each one of those. First is to eliminate the hazard. Ideally, every workplace and every job site will have 0 hazards. Of course, in reality, that's not possible. The second is to engineer out the hazard. So basically what OSHA is saying is if there is a hazard, can you make designs to get rid of that hazard? For example, a company re-engineers their HVAC system as to eliminate a fall hazard. The third is administrative controls. Basically what this means is companies put certain procedures in place to eliminate fall hazards. For example, a company may say that if work is to be done on a rooftop, 90% of that work must be done on ground level before that work gets moved to the rooftop. And the fourth is PPE. PPE, of course, stands for personal protective equipment. It's personal. It protects you. Examples of personal protective equipment are, in fall protection, are harnesses, personal fall limiters, restraint lanyards, self-retracting lifelines, of course, hard hats. In fall protection, we talk about the ABCs of fall protection. Well, what does that mean? The A stands for the anchor point, the B stands for body wear, and the C stands for connecting devices. Let's start with A. A is the anchor point. This is the point from which you are going to secure yourself when you're working at heights. So what does that mean? Typically in a work environment, it's something structural. It's an I-beam. It is a concrete part of the building. It is heavy woodwork. Basically, this is where you are tying off as the worker to protect yourself in the event of a fall. Now, what constitutes a good anchor point? Well, the anchor point has to be able to hold at least 5,000 pounds. Basically, it has to be able to take the force when there's a fall and then some. So if you're a worker and if you think it can hold 5,000 pounds, then you can secure yourself to it. Think of it this way. Can you hang your pickup truck from that point? If you think you can, it's probably a good anchor point. If you think there's no way, it's not a good anchor point. An anchor point can also be determined by a qualified person, for example, an engineer, and at that time it only has to be rated for 3,600 pounds. So A is an anchor point. So once you determine what the anchor point is, how do you attach to it? Well, there are several things that I have here that are commonly used in the work environment. This is what's called an anchor strap. You put this around the anchor point, for example, an I-beam, something structural in the building. You attach to this and you'll be protected in the event of a fall. Another example is a beam clamp. This attaches right to the beam. You secure yourself to this D-ring and you're secure in the event of a fall. So that's A, anchor point. Again, we need to consider how much weight can the anchor hold and how do you attach yourself to that anchor point. Next is body wear. Body wear means a fall protection harness. Harnesses come in all shapes and sizes, but they're designed to be worn by the worker working at heights. When it comes to wearing a fall protection harness, the key word is that it is snug. The reason you want the harness to be snug when you're wearing it is because think of when you have a fall. When you have a fall, you're attached to an anchor device, which is attached to an anchor connector, which is attached to a connecting device, which is attached to you. A connecting device, which is attached to the body harness, which is attached to you. If this is too loose, several things can happen. First of all, there's been situations where you fall out of the body harness. Of course, this kind of defeats the purpose of the body harness. There's other instances where if the body harness is too loose, it's going to ride into parts of your body where you don't want that harness to ride. So how do you know if it's on at the appropriate tightness? First of all, with your leg straps, you should be able to fit your hand under the strap without movement. If you can fit your fist under the strap and move it around, then it's too loose. You need to tighten it up. Also, you need to look at the shoulder level. You shouldn't be able to move these off your shoulders. If you can, it's too loose. Also, if it's too loose, this centerpiece may ride right into your throat, and certainly you don't want that during the event of a fall. So this is body wear. Finally, and we'll talk about inspecting all of this equipment in a later portion. Finally, are connecting devices. So you've determined your anchor point, you've determined what's going to go around the anchor point or connect to the anchor point, you've got the appropriate body wear. Now you need to connect appropriately. Examples of anchor points are a personal fall limiter. This is designed to let you work in and out roughly at around 6 feet. You also have what's called a self-retracting lifeline. This can let you work at greater distances and will be attached at greater heights. All of these are going to connect to the anchor points. Let's talk about pre-use inspection. With any piece of equipment, you need to check it every single time you use it. Not once a month, not every other day, not when you feel like it, every single time you use it. Not only does OSHA require this, but you should want to do this because this equipment is designed to protect you. When you look at your body harness or any piece of equipment, there are typically 5 areas that we want to inspect. We want to inspect all the metal, the plastic, the webbing, the stitching, and finally the label. When I inspect a harness, I like to go do each group and then move on to the next group. So for example, check all the metal, then check the plastic, etc. You can go from top to bottom, whatever works best for you. So what are we looking for? When we're looking to check the metal on a harness, we want to make sure that it's not bent, cracked, rusted, deformed, or damaged in any way that could limit its use. So we're just going to do a quick visual inspection on the metal. This is a harness with a front D-ring. So we're going to check the front D-ring. We're going to check the back D-ring. Again, making sure it's not bent, cracked, rusted, corroded. We're going to check the connecting devices. This is what's called a quick connect. So we want to make sure that it will disconnect and stay connected. We want to make sure that the mechanism is both of these have to be pulled at the same time. So we want to make sure if we only do one, it's not going to come disconnected. We're going to check the buckles to make sure they're not bent, cracked, rusted, or corroded. This is a harness with leg tongue buckles for fastening. We're going to check each of these to make sure they're not bent, cracked, rusted, or corroded. We also want to make sure that they don't spin in their place. Finally, we want to make sure that no one added a hole before or after the last tongue buckle to ensure a better fit for them. And we'll talk about the webbing in a second. So that's the metal. The plastic on a harness typically includes the shim where the D-ring goes. This back D-ring goes into a plastic shim right here, and that's what keeps it secure. This also has a secondary shim in which you put a personal fall limiter, something like this. So that's the plastic. The third is the webbing. This is all the black on this harness. So what are we looking for? We're looking for any holes. We're looking for any tears. We're looking for any damage at all. We're looking for, has it been splattered by paint? A few paint drops here and there will probably get you through your day. However, if it's coated in paint, you'll want to get it out of service. The reason is the chemicals in the paint can break down the materials in the webbing in the harness. You want to look for chemicals. Does it have a few chemical drops on it? Again, like the paint, if you have a few, you can probably get through your workday, but if it's coated in chemicals, you want to get it out of service. Ultraviolet damage. If this black harness starts to look gray or white, you know that it's been used outside, and the UV damage can wear down the integrity of the webbing. So these are things that we're looking for. We're looking for any nicks. If you see even the slightest nick, you want to get it out of service. Think of it this way. When you go to the store and you buy shredded cheese, are you going to buy the package in which the top is pulled a little bit? Of course not. Same thing with your harness. If you see even a little tear or a little nick, you want to get it out of service. So those are the things that we're looking for on the webbing. And we're just going to do a quick visual to make sure that it's okay. The next thing we're going to look for is the stitching. Every harness has some form of pattern stitch. That's where the load-bearing points are on the harness. In this harness, it's a honeycomb. On your harness, it may be a circle, it may be a diamond, it may be a rectangle, it may be a variety of different shapes. But in this harness, it's a honeycomb. So we're going to look at all the stitching to make sure that none of the stitching has been pulled out, that it's all secure, that the harness has not been used. The last thing we're going to check is the label. Now you think, why do I need to check the label? Because the label doesn't have anything to do with the integrity of the harness. However, what the label is going to do is the label is going to tell you what the harness is used for. It's going to have the date of manufacturer. It's going to have the serial number. In this harness, the label is tucked in the back. You want to make sure that the harness is legible and that it's not damaged. If it is, per OSHA, you have to get that harness out of use, out of rotation. The same thing goes for your other equipment. So for example, this personal fall limiter, you've inspected your harness, that's good. On the job site, you're also using a PFL, a personal fall limiter. So we're really checking the same things. We're checking the metal, make sure it's not bent, cracked, rusted, or corroded, the metal of the carabiner, and the metal of the attachment. We are making sure that we're going to check, since we are talking now about carabiners, we're going to make sure that the swivel gate works, that it's a dual mechanism where you have to turn and it's automatic connect. We want to make sure that that hasn't been damaged. In this device, you'll see a red sliver. If this item had been used, this red would be a lot more prominent, and that would be an indication that this equipment was used in a fall and it needs to get out of service. So those are some things that you look for. You want to check the plastic, the housing. Okay, it's not bent, cracked, damaged in any way. You want to check the webbing. Do a quick pull out. Make sure there are no nicks, holes, or anything like that. When you use this equipment, you want to make sure that it's actually going to lock out. So you do a quick test. It's very similar to your seatbelt. You want to make sure it's going to work if you actually have a fall. The same thing goes for self-retracting lifelines. This one is a cable. Just like we're going to check the metal, the plastic, the housing, we're going to check the gate to make sure it's a dual gate mechanism and it's also an automatic release. But in this, we're going to check to make sure that the cable isn't frayed, that it's not damaged, it's not kinked, it's not bird caged. That means it starts to bunch up. So again, these are all pre-inspection things that we're going to check for. And then finally, if you're using a lanyard, again, we want to make sure that it's not bent, cracked, rusted, or corroded. This one actually has a little bit of rust on it. So I really need to consider, do I need to get this one out of service? I think this would be okay, get me through the workday. I don't think this would do anything to the structural integrity of the gate, but it's something to look for. On this harness, we're also going to check the stitching. Again, a honeycomb stitch pattern. We want to make sure that there are no nicks in the webbing, checking the metal, checking the webbing, checking the stitching, and this one looks okay. Now, what are some examples of equipment that failed the pre-use inspection? For example, this is a harness that I used in a drop demo in the past. You can see when I did that demo, this was used in a fall, and it pulled away the stitching, and there's a clear warning that says remove harness from use if visible. So if I'm doing my pre-use inspection and I come across this, I need to get this out of service immediately. This can happen if there was a fall, there's chaos surrounding the fall, and the equipment just gets thrown back in the pile instead of being removed. Another example is with this self-retracting lifeline. Every piece of equipment has what's called a load indicator. So in this piece of equipment, during normal use, these would be together. For example, like this. You can see that that's one unit. However, this was used in a drop. So therefore, this part comes apart and you see the red. The red lets me know during my pre-use inspection that this has been used in a fall. If that's the case, you need to get it immediately out of service. This is my friend Woody. Woody is a 220-pound test mannequin that we use to show the forces on the body when there's a fall. Now there's a couple rules of fall protection that we try to have Woody follow. The first, of course, is not to hit the ground. It fall protection, that is the #1 rule. We do not want to hit the ground. We want to make sure that we've thought about how high we're working and that we have the proper equipment so we don't hit the ground. The second rule of fall protection is we want to minimize the force on our body if there is a fall. Now there's a couple of ways that we can do that. The first is we can minimize how far we fall. So for example, if I'm using this 6-foot lanyard and I'm tied off to my back D-ring, if I attach parallel to my back D-ring, I'm going to fall the full 6 feet. However, if I attach above my D-ring, then that will lessen how far I fall. These are things to think about, and we'll talk about fall clearance calculation in 1 second. The second way we can minimize the force on our body is to minimize our weight. Does that mean we all need to go on a diet? No, what it really means is we need to limit the amount of equipment that we need to take up when we're working at heights. For example, if we're working at heights and we have a 70-pound tool belt, do we need every single tool in that tool belt to do that specific job? Think about it. If Woody here, 220-pound test dummy, brings up his entirety of his tool belt, which is maybe another 70 pounds, he's just increased his working weight from 220 pounds to nearly 300 pounds, which will generate a lot more force on his body. Now, when Woody is working at heights, one thing he really needs to think about is what we call the fall clearance calculation. Especially if he's using a lanyard, he definitely needs to think of the fall clearance calculation. So what does that mean? It means that Woody is working at heights, and Woody needs to make sure that he has enough clearance should there be a fall. So if Woody, imagine the worker, Woody, is 6 feet tall. He's using a lanyard that's 6 feet tall. In the lanyard is a shock absorber to help minimize the force that can tear out up to 4 feet. So right now we're up to Woody's 6 feet, the 6 feet of the lanyard, the 4 feet of the shock tape, we're up to 16 feet. If we build in 2 feet of protection, that gives us 18 feet. So if you look at the top of my arbor, the arbor is 18 feet high. So what we're going to do is we're going to bring Woody up. He's going to be working at heights at 18 feet, and we're going to drop him to see what happens, to see if he properly calculated the fall clearance based on his equipment and based on the job he's doing. As you can see, Woody is working at heights right now. His anchor point is 18 feet in the air. Woody is 6 feet tall. Woody's using a 6-foot lanyard with a 4-foot shock absorber. So that equals 16 feet. We're going to build in 2 feet of buffer just to make sure that Woody's safe. Now what we're going to do is Woody's going to have a fall. And we're going to see if Woody's fall calculation was correct. This will also give you an idea of the forces on the body during a fall from heights. And 1, 2, 3. Well, looks like Woody took quite a jolt there. You can see that the tear tape didn't come out completely, and I'm roughly 6 feet tall, and if that's the case, Woody's feet may be tickling the ground, but by and large, he did the proper fall clearance calculation. However, you can see it's pretty close. If the tear tape came out even a little further, his feet might hit the ground, and he would have violated that first rule of fall protection, which is don't hit the ground. But you can see that all in all, Woody selected the right equipment for working at heights in this instant. But what do you do when you're working at heights and you're below 18 feet? Well, you can see at the top I've got a self-retracting lifeline. We're going to hook Woody up to that self-retracting lifeline and see what happens. Okay, we saw what happened when Woody fell from a height, tied off with an 18-foot anchor point. He had a 6-foot lanyard, 4-foot shock pack. He himself is 6 feet tall, and he had the proper equipment. However, what if Woody's working at a height less than 18 feet? You can see here he's attached at the top of my arbor at the anchor point to a self-retracting lifeline. He's much lower than 18 feet. Do you think he's going to hit the ground? I don't know. Let's see. Obviously he didn't. And the point is that when you're working at heights, you absolutely have to make sure that you have the right equipment. If you're using a lanyard, you have to do a fall clearance calculation to make sure that you're high enough for that equipment. If you're below 18 feet or 20 feet, you need to make sure that you have a self-retracting lifeline or perhaps a personal fall limiter that will protect you in the event of a fall. Okay, you've had a fall, but you're safe. You had the right equipment, you respected the equipment, it worked for you. However, the equipment, this harness for example, that just saved your life is now working against you because you're hanging, all your blood is pooling to your lower extremities, and this harness that you made sure was snug when you put it on is cutting off the circulation. So what do you do when you're hanging there before help arrives? First of all, your company should have an emergency response in place. Ask your safety supervisor and safety specialist at your company what that plan is before you work at heights, just in case. So if you are working at heights and you have a fall and you're hanging there, what's happening is called suspension trauma. The blood is pulling in your legs, you're building up what's called lactic acid, and you're just waiting to be rescued. So what can you do? One thing that you can do is you can pump your legs, just like this. What this does is this helps the blood recirculate to your heart, get oxygen, and get rid of some of that lactic acid. Another thing you can do is every harness is designed with a seat. You can position yourself so you're essentially sitting on that part of your harness. Okay, it might take some maneuvering as you're hanging, but it can be done. The next thing you can do is get this extra equipment. If you're hanging at heights, you have this attached to your harness. You can put your feet in here and essentially tilt yourself back and get yourself in a position where gravity doesn't play as much of a role in the blood pooling in the lower extremities. Okay, great, you've done all that. Help arrived very quickly. Now what do? As soon as you're on the ground, you have to remember that you have a lot of blood pooled in your lower extremities. We want to make sure that that blood gets to your heart and the rest of your body in a controlled manner. So I'm going to get on the ground and show you the best position. If you've had a fall and you've been rescued, this is the position to get in. When you sit this way, with the bend in your knees, that's going to help control the blood going from your lower extremities where it's been pooling and developing lactic acid back to your heart and to the rest of the body. What you don't want to do when you have a fall is lie down flat. You don't want to walk around. You just want to get in this position. 5, 10, 15 minutes, whatever it takes. Just give your body a chance to recover from the trauma that was the fall. Thanks for watching. Hopefully you learned something today that will protect you as you're working at heights. Remember, if you have the right equipment, you check your equipment, you think about the environment that you're working in, you're going to be safe at the end of the day. We can't avoid all accidents, but if we put our mind to it, we can make sure that we're safe and unharmed and go home to our families.